This video is the practice problems for Chapter 2, Chemistry. And we will just be working the problems. We won't be, in this video, we won't be answering the questions in the review section that are not problems. Okay, so we're going to start with number 3. And number 3 says that a student does a chemical reaction with 2 chemicals. The total mass of the 2 chemicals is 45.0 grams. When she is done, she finds that the mass of all the chemicals she has collected is now 34.5 grams. Has she collected all the products of the reaction? And the answer to that would be no, because the law of conservation of mass tells us that in any chemical reaction, the mass of the chemicals that you begin with will equal the mass of the chemicals that you end up with following the chemical reaction. So if she only ends up with 34.5 grams, that means that she has not collected everything, because it should add up to 45 grams. Okay, number 4. In number 4 refers back to question number 3. So again, the chemicals that she starts with are 45 grams, and she collects 34.5 grams. So then question number 4 asks us, what is the mass of the chemical or chemicals that the student did not collect? So the mass that she started with was 45, and she collects 10.5, or 34.5. So she failed to collect 10.5 grams of one or more chemicals. Okay, number 6. A 75 gram sample of a white powder. We start with 75.0 grams of white powder. And that white powder is broken down into 29.86 grams of copper, 15.06 grams of sulfur, and an unknown amount of oxygen. So part A asks us how much oxygen would there have been. Okay, so we start with, if you start with 75, then the mass of these 3 needs to add up to 75. So 75 minus 29.86 minus 15.06. And that will give us, for the oxygen, you're going to get 30.08. Now, in terms of significant figures, because we're subtracting here, we're going to go to the value that, so this, the least precise value. So this goes out only to tenths. So our answer would be 30.1 grams of oxygen. Okay, then the question says, so that's part A. the answer would be 30.1, so that now this plus this plus this is going to give us our 75 grams that we started with. Okay, then part B says, suppose you want to make 11.2 grams of white powder. If you wanted to make 11.2 grams of white powder, how much copper, sulfur, and oxygen would you need? Okay, so this problem is, you can think of it in terms of when you bake or cook something, if you want to double the recipe or if you want to cut the recipe in half, then you have to either double all the ingredients or cut all the ingredients in half. So what we have to do is we have to look at what is the ratio between the amount that you want to make and the amount that your recipe. So this up here that we've done, that's like our recipe to make 75 grams, but we only want to make 11.2 grams. So we're going to take 11.2, the amount that we want to make, and we're going to divide it by 75 grams. So 11.2 and it's 75.0. So with 3 significant figures here, then we get 0.149. Okay, so then, so 75 times 0.149 will give us 11.2. So then what we do then is for each of the 3 chemicals, we're going to multiply the amount that we needed to make 75 grams by this multiplier 0.149 to get the amount that we'll need to make 11.2 grams. So we're going to take 29.86 times 0.149. So that's how much copper we will need. 29.86 times 0.149 gives us 4.45 grams of copper. Okay, and then for sulfur, we'll do the same thing, 0.149. So 15.06 times 0.149 will give us 2.24 grams of sulfur. And then lastly, we'll do the same thing for the oxygen. So 30.1 times 0.149. So 30.1 times 0.149, we would need 4.48 grams of oxygen. So these are the amounts that we would need to make 11.2 grams of the white powder. 4.45 grams of copper, 2.24 grams of sulfur, and 4.48 grams of oxygen. You can double check yourself to make sure that you have the right answers by adding those 3 together. And when you add those 3 together, you should get 11.2. So when I add these 2 together, I get 11.17. And because of rounding, that's 11.2 grams. Okay, so that tells you that the amount of each chemical that you calculated is correct if they add up to the amount that you wanted. Okay, next we will move on to question number 7. Okay, question number 7 says that a chemist makes 86.94 grams of a black powder. And we are told that that black powder is made by reacting 54.2 0.94 grams of manganese and 32.00 grams of oxygen. Okay, so these two are mixed together and they yield 86.94 grams of black powder. Okay, so then the next part of the question says that instead of breaking down 86.94 grams, what if the student breaks down 144.9 grams? So again, this is just like the one we did previously, where we want to look at what is the relationship between the amount that we want to make and the amount that we made initially and have the recipe for. So we would take 144.9 divided by 86.94 grams. Grams are going to cancel, so it will just be a ratio. So 144.9 divided by 86.94 gives us 0.1 point and then repeating sixes. And we can have, looks like 4 significant figures, so it would be 1.667 would be our ratio. Okay, so that's the amount that we want to make is 1.667 times the initial amount that we had. So to make 144.9 grams of the black powder, we would multiply the amount of manganese times 1.667. So 54.94 times 1.667 will give us 91.58 grams of manganese. And then we'll do the same thing with the oxygen. 32 times 1.667 will give us 53.34 grams of oxygen. Okay, so I multiplied this times the multiplier 1.667. Okay, so to make 144.9 grams of the black powder, we would need this much manganese and this much oxygen. And again, you can check to see if your numbers are correct by adding those two together. And when you add those two together, you should get 144.9. When I add them together, I get 144.92. And again, because of rounding and significant figures, this will be 144.9 grams, which agrees with the amount that we want to make. Okay, then number 8 is also going to refer us back to number 7. So let's write the numbers back for number 7 to start with. So we had 86.94 grams of a black powder. And that was made by reacting 64.94 grams of manganese and 32.00 grams of oxygen. Okay, so that's what we had in question number 7. Okay, so now this question, question number 8, says that you're going to react 7.8 2.85 grams of manganese and 2.29 grams of oxygen, and that is going to give us 10.14 grams of that powder. Grams of a powder. So then this question asks us, is this the same powder that we made up above? So for this one, the thing that you have to remember is that if two compounds are mixed together in the same proportions, then they will produce the same chemical, the same outcome. So what we need to do then is we need to look at what is the ratio between the manganese and the oxygen. What is the proportion between the manganese and the oxygen in each case? So this one will take 54.94 grams of the manganese, and we use 32 grams of oxygen. Down here, we use 7.85 grams of manganese, and we used 2.29 grams of oxygen. Okay, so what is the proportion between those? So 54.94 divided by 32 with four significant figures, 1.717. So in other words, the manganese, you have 1.7 times as much manganese as you do oxygen. And then if we look at the ratio down below for the powder that we made below, 7.85 divided by 2.29, now the ratio that we get is 4.428 with three significant figures. So I guess this one would just be 3.43 is our ratio. So here there is over 3 times as much manganese for each oxygen. Here there's only 1.7 manganese for each oxygen. So since those ratios are not the same, the two powders that were made from those chemicals were not the same. So even though we used the same chemicals, they were not used in the same proportions, and therefore they don't produce the same compound. Okay, the number 9 says that in an experiment, a chemist reacts 10 grams of manganese with 5.8 grams of oxygen to make 15.8 grams of a powder. Is this the same powder as in number 7? Okay, so let's write out again what we had for number 7. We had 86.94 grams of the powder, and that was made by mixing 54.94 grams of manganese and 32 grams of oxygen. And we determined previously, if we look at the ratio between the manganese to oxygen, so manganese divided by oxygen was 1.717. Okay, so then question number 9 says we are going to mix 10 grams of manganese and 5.8 grams of oxygen, and we will make 15.8 grams of powder. And now we want to know, is this powder the same that we had above? So again, we want to look at what is the ratio between manganese and oxygen. So manganese was 10 grams, oxygen was 5.8 grams. Grams cancel, so it's just going to be a ratio. 10 divided by 5.8. $1.72. If we go to 3 significant figures, which we can do, actually we can just go to 2 significant figures. So this would be 1.7. So comparing this ratio to this ratio to the same number of significant figures, they are identical. So that tells us, since the ratio of manganese to oxygen is the same in both cases, then the compound is the same powder. Okay, number 12. A chemist makes 2 different compounds from the same elements, tin and chlorine. Okay, so in the first case, he's going to react 50 grams of tin and 29.87 grams of chlorine. And there are no leftover of either element. Okay, so if there's none left over, then that means that the total mass of the compound that we end up with when following this reaction will be 79.87 grams. So this is compound, we'll call this compound A. Okay. Then for compound B, we're going to react 50 grams of tin, so it's the same amount of tin, same mass of tin. And we're going to react 59.74 grams of chlorine. And there's none left over, so that would mean that the mass of the compound that we make would be 109.74 grams. So we'll call this compound B. Okay, so if the first compound has 2 chlorine atoms in the molecule, how many atoms of chlorine are in the second compound? Okay, so if this amount represents 2 atoms of chlorine, how many atoms of chlorine are in compound B. Okay, so we look at the mass of the chlorine. Here it's 29.87, here it's 59.74. So again, let's look at the ratio between those two. 59.74 grams divided by 29.87. So 59.74 divided by 29.87 gives us that the ratio is 2. So in other words, compound B has twice as much chlorine as compound A. So if there are 2 atoms of chlorine in compound A, then there must be 4 atoms of chlorine in compound B, because the mass is twice, the mass of chlorine is twice as much of that which was in compound A. So then the last one that we will do, actually we'll do a couple more, we'll do 2 more. We'll do number 13. A chemist makes 2 different compounds using nitrogen and oxygen. In the first one, it's 10 grams of nitrogen and 11.42 grams of oxygen, and you make 21.42 grams of, we'll call this compound A. It's actually a gas because nitrogen and oxygen are both gases, so we'll call it compound A. And then in the second case, we start with 10 grams of nitrogen, and for oxygen, we aren't told how much oxygen, but the question says, if she starts with 10 grams of nitrogen but wants to make a completely different gas with no leftovers, should she use 20.5 grams of oxygen? Should she use 22.84 grams of oxygen, or should she use 35.12? So those are the 3 choices that we are given. So what you have to remember in answering this question is that atoms of oxygen occur only in whole numbers. So if she wants to make since both gases have the same amount of nitrogen, in order to make a different gas, the ingredient that she would change would be the oxygen. And that oxygen can occur only in whole number multiples. So if she starts with 11.42 grams, then she has to look at a number that is twice as much as this or half as much as this. And so the only of these 3 choices, the only one that works is 22.84 grams, because that is twice as much oxygen. So if this represents 1 atom of oxygen, then this amount would represent 2 atoms of oxygen. If this represents 2 atoms of oxygen, then this one is twice as much, so this would represent 4 atoms of oxygen. Okay, so the key there is remembering that atoms in chemical reactions, atoms occur only in whole numbers, not in partial amounts of an atom. Okay, the last one that we will do is number 19. Which of the following atoms would be an isotope? So here's our choices. We have A, B, C, and D. So A says we have 13 protons, 14 neutrons, and 13 electrons. B is 14 protons, 14 neutrons, and 14 electrons. C is 13 protons, 12 neutrons, and 13 electrons. And then D is 15 protons, 16 neutrons, and 15 electrons. Okay, so what is an isotope? An isotope is a form of an element. So an isotope is the same element, but the element has different numbers of neutrons. So, and the thing that determines whether something is the same element is if they have the same number of protons. So when we look at our choices here, A and C both have 13 protons, so that tells us they are the same element. And then if we look at their number of neutrons, we can see that A has 14 neutrons and C has 12 neutrons. So same number of protons, different numbers of neutrons. So A and C are isotopes of each other. Okay, then number 20 asks, which of these two, A or C, would be the heaviest? So the only thing that's different between them are the number of neutrons, and neutrons have a very, very small mass, but they do have some mass, and therefore the one that has the most neutrons would be the heaviest. So A, because it has 14 neutrons and C has 12, A would be the heaviest. It would have the greatest mass of the isotope, looking at A and C. Okay, so that is it for the problems that are in chapter 2.